This presentation was made for Globalization and Technology Strategy, taught by Dr. Pratim Datta at Kent State University in spring of 2023. It was prepared by Reece, Denon Hubbard, Connor Hall, Alex Kelly, and Braden Meyrl. It covers what IoT devices are and what their place is in the field of architecture. We question how IoT devices can change architectural design and modeling, both regionally and globally, as well as the potential and challenges these devices will pose in the field. So, what are IoT devices? IoT in this context stands for the Internet of Things. It can be formally defined as a paradigm in which objects equipped with sensors, actuators, and processors communicate with each other to serve a meaningful purpose. Some examples of IoT devices can be seen in the graphic and include but are not limited to smart refrigerators, smart lights, drones, smartphones, smartwatches, VR headsets, smart thermostats, and cars. It is important to note that these objects have the word smart associated with them because a refrigerator without smart function is not an IoT. In short, what makes these everyday objects part of the IoT is their ability to connect to the internet and communicate with other devices and you. The next question to be asked is how IoT can work as an architectural mechanism. Two examples that are currently being used in the field are VR headsets, or virtual reality headsets, and drones. VR has allowed architects, designers, engineers, clients, and all other entities involved in the building process create and immerse themselves in their projects without actually building them yet. Drones are another smart tool being used in the field for many helpful reasons. They are able to photograph and video sites, cities, buildings, rooms, etc. This is done quickly so designers can then generate digital and physical 3D models of their surroundings. Both of these tools can also be used in architectural academia to aid and teach architectural thinking with more theoretical-based projects. IoT devices can serve as a control center for buildings and homes after construction and the building process is finished. People are able to control the lighting, temperature, locks, vacuums, and more.
After discovering what IoT devices are and some of their purposes, let's discuss how they can and could be implemented in the world of architecture and engineering. IoT devices are slowly creeping into our everyday use, with the likes of smart home devices such as Alexa and Google Home and the thermostats, but also things we use in our day-to-day like smartphones, our cars, and to some that use them, smartwatches. Each of these things is all around us and is projected to triple in size within the next decade. Architecture is similar in the realms of the technological world as it is constantly evolving and is something people must experience or live with daily. Just the past few decades and in the third industrial revolution, architecture and its building techniques have been evolving to become more sustainable, green, longer lasting, and less impactful to modern society. In the past few years, the focus has been achieving LEED status on buildings. LEED stands for Leadership in Energy and Environmental Design. This status is granted as either certified, silver, gold, or platinum, of which you must earn points that address carbon, energy, water, waste, transportation, materials, health, and indoor environmental quality. For the architecture world, LEED is the twin sibling to the Sustainability Development Goals. The use of IoT devices has made a large impact on reaching these LEED statuses and makes it a lot easier for those to achieve said status than it was 20 years ago. As upcoming architects within the professional world, these devices can be used either during the design process or the project. As I will explain in the next few slides, these devices can be used within the design process and project management, as well as within the building itself once complete, leading to that LEED certification. One of the most important aspects of a project is the design development and the site maintenance. Back in the day, before technology and software, there were drafting tables and pencils, but today we have Revit and AutoCAD to help with the computer-aided drafting. Revit heavily has been using BIM modeling techniques to help in the process and speed things up, to be more accurate for the designers, engineers, and project managers on site. BIM modeling, also known as building information modeling, the past few years has been progressing in using IoT devices and software. Specifically, it is using real-time 3D scans of systems, using artificial intelligence for system placement and structuring, and the implementation of cloud sharing the model to clients, designers, and engineers for a more streamlined design process. Next is using different rendering tools and software using the cloud, artificial intelligence, and even tracking devices to help maintain and complete the renders needed for the design phase. Renders are being more widely used to help show clients and the public what the finished product might end up looking like. Lastly, as the building is being constructed, there are different tools and devices that can be used on site to help maintain and control the construction. IoTs can be used for real-time tracking of materials, people, transportation, and data. This makes the construction process much easier to track and ensure things are running according to plan. Being able to track and see maintenance issues on vehicles before they break, and having a 24/7 on site camera allows the architect or the client to track the process of the project. In order to obtain the LEED status for a new building, there is a load of different IoT devices that can provide useful data, inputs, and mechanisms that can help achieve that status. Some of the different categories of devices that help are security, lighting, HVAC, energy power consumption, and disaster prevention.
The Internet of Things technology has the potential to revolutionize the way we live, work, and interact with the environment. In architecture, IoT devices can be used to improve efficiency, sustainability, processes, and safety of buildings and cities. Regionally, IoT devices can be used to improve the energy efficiency of buildings. Smart sensors can monitor temperature, humidity, and occupancy and adjust heating and cooling systems accordingly. Lighting systems can be programmed to turn off when rooms are unoccupied, saving energy and reducing costs. In addition, IoT devices can be used to monitor and control the use of water and other resources, reducing waste and promoting sustainability. For example, the Project Mav Home provides an intelligent agent which uses various prediction algorithms for doing automated tasks in response to user-triggered events and adapts itself to the routines of the inhabitant. Globally, IoT devices can be used to create smart cities that are more efficient, safer, and more sustainable. Smart traffic management systems can reduce congestion and improve safety, while smart waste management systems can reduce litter and pollution. IoT devices can also be used to monitor air quality and reduce the impact of pollution on public health. An example of IoT potential in growing cities today is Barcelona and Stockholm. Specifically, Barcelona has a City OS project where it aims to create a single virtualized OS for all smart devices and services offered within the city. They have mainly focused on smart transportation and smart water supply lines. However, they are expanding to smarter infrastructure, which could be the future of city building. The potential of IoT technology and architecture in the future is quite expansive, some of which are highlighted here. Data-aided installations refer to systems that receive data to generate a response. This capacity of data-aided design opens up tremendous possibilities for real-time interaction between users and their surrounding environment. For example, structures that connect over the internet and respond to a combination of visitors' presence and environmental factors by way of luminous fibers. Architects can also use big data in the final product's process and design. As an exemplary model of big data use in architecture, data from mobile phones' influence on monthly consumer spending were utilized by Synthesis Design and Architecture in collaboration with IBM Watson Analytics to create an interior wall and its spinning patterns, shown here. Leaning on the Internet of Things in the construction industry contributes to the efficient completion of a project by saving time and cutting expenses. Lastly, IoT sensors can be used to detect early signs of natural disasters and trigger warning systems in buildings.
IoTs are changing the way in which architecture is conducted. They have a huge influence on how a practice can be ran. Real-time updates of drawing sets, online model making, and up-to-date changes of feedback are only a few of the many ways that IoTs are changing the architectural practice in the world today. IoT devices begin to allow for a more modular and flexible designs, as a new component can easily be added or removed from every drawing. IoTs can help optimize the use of resources and reduce energy consumption, creating a more sustainable design. Creation of smart spaces will allow for AI to adapt to the needs of the occupant within the given space. On the regional scale of the IoT devices, these devices can help track and plan within a strong urban setting. Devices are able to conduct real-time data on traffic flow, air quality, and other urban environmental conditions. Real-time tracking can be used in multiple ways for disaster prevention. Smart transportation can help architecture improve the public network and reduce congestion within an area. Using IoT devices will allow architecture to become more efficient and sustainable. Architects, with the help of AI, are able to design and build infrastructure that is better suited for the needs of the community and help improve the quality of life. Within the global setting, IoT devices allow for architects and urban planners to collaborate and share practices across the borders. This will lead to more adaptation of different climates and regions for the architect. IoT devices can enable remote monitoring and management of buildings and infrastructures, meaning that management can be achieved anywhere in the world. This will lead to less travel expense and a more cost-effective project management. IoTs will be helpful when detecting areas that need work and then offering different development solutions to create more effective and sustainable designs within the world today.
Recommendations for the future. Architecture is an ever-changing and adapting profession. As it grows, the IoT devices it relies on must also adapt and evolve to suit the new needs of the work and the changing existing needs. As data information gathering becomes more and more complex, the information that IoT devices collect needs to be translated in a way that allows it to tell a story. In addition, the need for organized information will become increasingly apparent with the invention of new IoT devices that can manage complex information. Connectivity and collaboration will only grow with the abilities of IoT devices in the profession. This growth will be imperative for analytics and occupancy studies to assess design after the fact. Therefore, it is paramount that IoT devices continually grow for connection and collaboration to assist the profession.